Is there a magic number that you suggest?
Short answer, no, because I don't want to be held to it, and because I think it is still a moving target, frankly.
Hi, everyone, and welcome to another episode of #FoodTruth, where we will be talking all things food with incredible experts from how food impacts our health, our environment, and our behaviors. I'm your co-host, Sharon Cryan, attorney turned food nerd.
And I'm your co-host, Dr. Kevin Lyon, family medicine physician and co-founder of the Anti-AGEs Foundation. Today, we'll be talking about sulforaphane, phytonutrients, and the role within our dietary guidelines. Today's guest is Dr. Jed Fahey. Dr. Fahey is a nutritional biochemist with broad training and extensive background in plant physiology, human nutrition, phytochemistry, and nutritional biochemistry. He spent 27 years as a faculty member at Johns Hopkins School of Medicine. Until retiring last year, he ran the Coleman Chemoprotection Center, which he helped to create, and which has for many years developed plant-based agents such as broccoli sprouts for the purpose of enhancing health span.
Awesome. It's a pleasure to have you back again, Jed. Thank you so much for being a guest today.
Thanks for having me. I'm always excited to talk to people about plant foods and what they contain and why you should eat them if you can. And of course, everybody can.
Right. So kind of from our last episode, can you just give a quick, brief definition of phytochemicals real quick?
Yeah, so certainly, and I should preface it by saying that those of us who deal with these things, phytochemicals, every day, are somewhat conflicted nowadays about what term to use. Should we call them phytochemicals or phytonutrients? And I always used to hate the word phytonutrients because I didn't think it was very accurate, and I was a nutritional biochemist. On the other hand, I see consumers sort of bristling when they hear the word chemical in any context, which is sort of unfortunate, but whatever. So I'm sort of liking the word phytonutrients these days a little bit more. They're one and the same thing. So whichever you call it, phytochemical or phytonutrient, my definition is that they are compounds that are produced in plants in response to environmental stressors like water scarcity, ionizing radiation, or insect attack, or fungal or bacterial attack. And they lend the color, flavor, and odor to many fruits and vegetables. Some of them are toxic, or certainly some of them are toxic to some species of organism, not necessarily to mammals, though. They're ingested by humans at concentrations that are very, very, very low and are far below the threshold that would be required to produce illness. So, for example, too much salt, too much water can kill you. Yes, too much of just about any phytochemical could kill you too, but we don't get anywhere near those amounts typically. So what these compounds do then, these phytochemicals, when mammals ingest them in low quantities, is they switch on a vast array of responses that protect cells from harm. And this is a biological phenomenon that's referred to as hormesis. If I can blather on just a little bit more, I'd like to just emphasize the fact that they are present in really, really low concentrations compared to proteins, carbohydrates, fats, and fibers, which make up the vast bulk of plant matter. And there are, by various guesses, and these are all educated guesses by people who work with these things all the time, between 50,000 and something like 5 million of these compounds. And that's a huge range, I realize, but they've been described as the dark matter of epidemiologic studies, dark matter of nutrition. And this is because there's so many of them that frankly, it's hard to get your hands around which one is doing what. Anyway, time for me to shut up and take another question.
So thank you for clarifying that, because I think that's something, whether we call them phytochemicals or phytonutrients, but then I think most people think of this as they just call them antioxidants. Can you kind of talk a little bit about when people refer to them or people see antioxidants, on packaging or on supplements and things like that? Can you talk about, are they the same exact thing, or how can you kind of explain that to people?
Yeah, so that's has I don't want to say this after every one of your questions because I assume they're all good questions, but that's a great question. So, and thanks for asking because it's an opportunity for me to talk for another couple of hours now without interruption. Um, so early on, when people in the supplement industry and people talking about the quality of foods started talking about what they do, one of the things that bubbled to the top was this concept that there's an antioxidant function in many phytochemicals. And vitamin C is sort of the classic example of that, and vitamin C is indeed an antioxidant and something that we need. And one of the many things it does is that it acts directly to neutralize reactive oxygen species and other oxidants that we ingest or that are in our environment. But it's used up very quickly and then it's gone. It's out of your bloodstream. It's out of your body. Um, so as various phytochemicals started to get some research attention. This is back in the 70s, I guess, and the 80s, sort of some of the early phytochemical studies. A lot of them had antioxidant function, and that's cool, and that's true. And so that really, I think, defaulted. A lot of people have written about this, but I believe this defaulted to sort of become a buzzword and a hook for the food industry and the supplement industry, mainly for the supplement industry. What better than to sell something that's an antioxidant in a pill, and then you can eat steak and potatoes and not worry about getting all these wonderful phytochemical rich veggies. At least certainly a long time ago, that was an attitude. And so then they're developed a whole variety of assays for antioxidants, and it turns out that none of them were universally useful. They were all sort of complicated. Many of them were difficult to perform, and there were silos of investigators that used one kind of antioxidant assay or another. And so consensus was really hard to reach. And although the regulatory agencies allowed some antioxidant claims at one point, for a while, I should say, they sort of backed off of them more recently. And antioxidant claims are now, I believe, perceived as something that, there's antioxidant activity in a lot of compounds and a lot of foods. But these are not useful claims because there's still not a consensus on how important they are, how to measure them, and in the grand scheme of things, whether they have tremendous impact on health or health span. So, and then there's another class of compounds which I know you wanted to talk about with me, and we can get into this later, but a class of compounds that upregulate or induce or prime the antioxidant enzyme system, the antioxidant protective system in a human body, a mammalian system. And those are all phytochemicals that we found very interesting a long time ago, because there you have an opportunity to crank up enzymes that are what the body uses naturally as antioxidants. They produce things like glutathione, which is the body's most prevalent antioxidant, and their effect keeps going once induced for a period of certainly many hours, in many cases, many days. So you're not using up this phytochemical as an antioxidant directly. And we call that an indirect antioxidant effect. So I think I answered your question, but tell me if
Yeah,
I
no, you
did.
did. Excellent. No, you did. And I think that's one of the difficulties that I've come across when trying to explain phytonutrients, and how they're different from minerals or vitamins, right? Which is very commonly understood, micronutrients. But then there's this whole other category, which is the phytonutrients. But then I find myself wanting to just even be a part of that and just try to summarize it. Well, they're similar to antioxidants, and people are like, oh, okay, I understand antioxidants. But what you're saying is that that's just one potential benefit of them, but there's so much they're so much more complicated, and that there's so many other functions that they perform, and that just having an antioxidant effect doesn't do phytonutrients justice.
Oh, absolutely, absolutely, and in fact, you can, yeah, I mean, truer words were ne'er spoken. So if you look at, if you, again, go back to the definition I gave you, or tried to crystallize, of phytonutrients or phytochemicals. Um, they're not carbohydrates, proteins, fats, or fiber. What I should have also said is, add to that list of things that they're not vitamins and minerals. Okay. So nobody has pegged them as things that are absolutely required for our human nutrition, for our life. And that's true. So you could survive, and unfortunately, well, some people do survive with very, very few phytochemicals or phytonutrients because they just don't eat anything plant. This is the meat and potato diet, or the uh, soylent drink diet or something. But so there are, what, 13 essential vitamins, and there are a bunch of minerals, magnesium, calcium, potassium, so on and so forth. Those aren't phytochemicals either. So phytochemicals are present in even smaller quantities than those things, and they are not absolutely required for life. But many of us are realizing, and have realized over the last 20, 30, 40 years, that they are required for optimum health. They are phytochemicals, that is, they are required for health span, to allow you to live a long life without a bunch of chronic diseases creeping in and making you less and less able, less and less vigorous, less and less vital. And then one day you don't wake up when you're 100 years old. And that's what phytochemicals are essential for. So when you say they're not just antioxidants, let's think about some of the things that they are, in addition to, in some cases, being antioxidants. In some cases, these phytochemicals are not antioxidants at all, but some of them have potent antibacterial activity, and maybe are not antioxidants. Some of them have potent antiviral activity and maybe are not antioxidants. Some of them inhibit phase 1 enzymes or cytochromes that are responsible for a lot of drug metabolism and are not antioxidants. Now, that effect you might view as, in some cases, and depending on what medications people are taking, maybe that's not a good thing. And the classic example is grapefruit or grapefruit juice, and some meds. Some phytochemicals act to inhibit cell cycle progression, or to create apoptosis, or the directed death of cells in cancers. Wow, isn't that cool? Um, some are potent anti-inflammatory agents, but again, not directly antioxidants. Some potentiate the immune system, but again, are not potent antioxidants. So the list goes on. I've tried to hit some of the ones that come to mind first, but so there's a really wide range of activities of these compounds, and they're not all antioxidants. Full
No, that's
stop
a
for a
great.
second.
So I do want to touch on that. I think you made a really great point that it's important to understand these phytonutrients aren't necessary to sustain life, but they are ideal for an optimum nutrition. And kind of given what we know, especially in the medical community, We talk about like RDA values for macronutrients and micronutrients, and it sounds like there's a lot of research out there showing the promise and all the health benefits of these phytonutrients. But do you foresee a future where there's going to be a quantifiable amount, some sort of eventual guideline as to how much you really should be consuming in a day?
You know, as with all of your questions, Kevin, that's a great question. Do I foresee it? I hope for it. Yeah, I hope for it. But the complicating factor is that you don't have to have them, right? So if you don't have to have them, then could there be a recommended intake, recommended daily intake that's sort of divorced in a way from the dietary recommended intakes that we're used to seeing? And I think so. And I do, excuse me, I do hope so, because I think this would really help guide people's consumption of fruits and vegetables, especially fresh fruits and vegetables. Um, the regulatory agencies have been pretty darn silent on that subject for forever. And the USDA, which of course is the handmaiden to big food and is beholden to meat and dairy industries and soy and corn, but the USDA has been conspicuously silent on this also. They've paid lip service to talking about phytochemicals. In fact, they now, with pushing from a lot of us in the phytochemical community, they started a database of glucosinolates in plants, and one for flavonoids, and I believe there was talk about doing one for anthocyanins. These are very incomplete databases, and certainly they are light years away from making recommendations. But your question is such a good one, because it gets to another problem in conceptualizing this. You know, I said various estimates are between 58,000 and 5 million or 10 million even phytochemicals. So obviously those aren't all in all plants, so they're spread out among the ginormous, to use a very precise term, the ginormous population of plants. Some of those plants are toxic and poisonous, of course, and we don't eat them. Some are things like oak trees. We don't eat oak leaves, but we might eat acorns. So yeah, there are different phytochemicals in different parts of plants. And they're spread all over the world. So there are millions and millions of different species of plants, and certainly hundreds of thousands of edible plants. How, in a place like America, where we're recording this podcast, even in a place like America, where people have free choice and have grocery stores at which they get their fruit and veg, how would you sort of make that list of phytochemical requirements when the phytochemicals contained in a banana, for example, are completely different from those contained in a pear? But I could argue, given time and some study, that this, and this phytochemical in banana are awesome for you, and this, and this phytochemical in a pear. In fact, let's get specific. A Bartlett pear versus an Anjou pear are freaking ridiculously good for you. But you don't like bananas and you don't like pears. Okay, so eat your bananas and eat your pears, but you got two completely different lists of good phytochemicals that you should strive to ingest. So it's difficult, and we need a lot better quality. That sounds disrespectful of existing phytochemists and nutritionists, but we need high quality thought to continue to develop these suggestions and recommendations. And I suppose you could, if there were any consensus on what healthy diets are, like you could isolate a Mediterranean diet and you could sort of categorize all the foods in it, and you could say, well, this, here are some of the phytochemicals in that particular eating plan, and you should strive therefore to get these. And then isolate a fresh diet, an uncooked raw diet, and do the same. It's difficult, and we want all the help we can get from the younger generations of inspired scientists like yourselves.
So I have a question. So obviously every plant based on its species is going to have a different profile of phytonutrients. But going another step further, it's not only the type of plant and its species, but how about the growing conditions and factors like that? Do those alter the phytonutrients? So for example, let's say large big crops that are maybe have different soil compositions and less soil health and less diversity around them. Are those factors that also can change the phytonutrient compositions within plants? And also organic versus non-organic, all those various growing conditions?
All of those things indeed impact phytochemical content. Yes, and the sort of I won't say the genesis. Well, I guess in a way it's the genesis, but what happened over time as humankind started screwing around with plants, which is to say, as they started breeding them and selecting cultivars or varieties or variants that they liked. A cultivar just means a commercial variety. Um, they started improving them for various things, but interestingly, most of those things they improved them for, almost all of them, I should say, were yield. How many pounds per acre, kilograms per hectare, et cetera, you could get out of a crop. For pathogen resistance, think of the Irish potato blight, it wiped out the whole crop. Well, Phytophthora infestans was the fungus, as I recall. And so, you either get away from the place where that pathogen is or you breed for resistance to it. And unfortunately, sweetness was another thing that was bred for, sugar content. So, I mean, what that leads to is something's got to give. You sacrifice something, and I guess, more importantly, it means you don't look at something. So you don't look at phytochemical content. If you're a plant breeder engaged in that sort of activity, whether it's for corn, wheat, barley, rice, or apples or pears, or blackberries, if you're breeding for yield and sweetness and disease resistance, you got your hands full, really full. And it takes years and years and years to develop a new distinct cultivar that looks and feels and tastes different, that in big food industry and big ag, that ripens at the same time, so you can go through with a mechanical harvester and don't have to pick it by hand when the fruit is ripe. All of that takes a huge amount of effort. Nobody looked at phytochemical content. And one of the I know that I believe you're in Buffalo right now. You're in upstate New York anyway. So, the Finger Lakes region in upstate New York is such a wonderful place for apples, for growing apples. And there are old apple orchards all around. I just actually read a book by a guy in Maine who dove deep into apple cultivars, and it's really interesting to go and look at some of the old cultivars, or even try some of the fruit off an ancient apple tree that you see sort of being neglected in an orchard. And the taste of some of those fruit is remarkable, and the texture too, not in many cases not anything like what you buy on the supermarket shelf. Well, they have a lot of phytochemicals that weren't bred out of them, um, for the sake of yield and tree shape and sweetness. And a lot of them are quite a bit tartar than current varieties. So anyway, I wax philosophical, but there you have it. So again, I hope I answered your question a little bit, but
Yeah, absolutely. So is it safe to say that I would say a bulk of the produce that we're getting at our grocery stores, for example, the main cultivated conventional crops that are out there, um, that they are in phytochemical content. It could be very different than the crops that our ancestors grew up on, or wild crops and things like that that are non-cultivated. They could be. Do you have a theory or an opinion of maybe the potential difference in phytonutrient nutrients?
Uh, Again, excellent question. And the answer is, of course, I've got a theory. Come on, give me a break. I've got a theory about it, but I don't know how good it is. And it's controversial. So, the the horticultural and agricultural establishment would fight you back on anything I might say to agree with you, because it's not in their best interest. On the other hand, I think it's become generally acknowledged that yes, there's a reduction in phytochemical content in some of these cultivars at the expense of the things we talked about. Um, you get so and there are good studies documenting that loss of phytochemical content, but uh, and I can share some of those with you. Same thing with organic versus conventional. Um, but it does, the reason those studies are not all over the place and they're not sort of the gold standard that everybody, including physicians who treat patients, know about. It goes back to that issue of there's so bloody many phytochemicals distributed over so many plants. What would you look at? Pick any commodity you want, or pick grapes, or pick, apples or bananas, anything. What phytochemicals do you look at to assess loss over time? Um, and so that gets very difficult. Um, and so it's a difficult question, even for well-intentioned scientists to ask. We know that there's an extraordinary loss of diversity. Actually, I have a slide someplace in one of my presentations that I took out of National Geographic magazine. They did 10 or 15 years ago, they did a study on loss of agricultural diversity, and they were looking at seed banks and so on. And they showed this dramatic graphic of the number of varieties of all of the common fruits and vegetables 100 years ago, and then fast forward to whenever it was, 2015 or something, um, showing the re- tremendous reduction in number of cultivars. And so that alone tells you that you've lost a lot of phytochemical resources that were in those cultivars that are no longer grown. Why are they no longer grown? Because other than, little farms, organic farms that sell their produce at farmers markets like the ones I shop at twice a week in Maine, nobody wants them because they don't fit nicely into crates and get shipped and get stored for 6 months in a supermarket warehouse and all that stuff. So, yeah, it's a difficult problem, but people are attacking it. And the answer is yes, there's a reduction. It's just difficult to put that in a one sentence bullet point in a USDA report or something. So it's not mainstream knowledge.
So, Jed, you just touched on it a little bit. You mentioned kind of difficulties in researching phytonutrients. So maybe you could expand on that a little bit more. Like, what are specific like bottlenecks or issues with researching the phytonutrients, and kind of where is the research right now? Where do you see it 5 years from now? Are there any human trials? How is it going to be applicated to medicine? Those sorts of things.
So, for instance, I mean, Kevin, your question was about the difficulty in doing phytochemical research, right? And
Hmm.
so, per se, it's not difficult. The chemical tools, the forensic tools, if you will, are out there to extract certain phytochemicals from extract any phytochemicals from plants and to identify them. And the tools are called mass spectroscopy and nuclear magnetic resonance spectroscopy. And all chemists know about them. So that's not difficult. But the question is really prioritizing and then prioritizing the compounds and taking them through to human clinical trials. So in a paper that my colleague Tom Kensler and I did that was published this March, I guess, in Food Frontiers, we have we looked at, for example, the top 40 phytochemicals from as they appear in the scientific peer-reviewed literature, and the most cited specific phytochemical was actually quercetin in our search, and there were between 40 and 50,000 citations for this compound. What does that mean? It means that scientists the world over published 40,000 papers in which they looked at the effects of quercetin in a cell culture system or in an animal model system or who knows what else, but mostly not in human clinical studies. And just for perspective, the bottom of our top 40 list of superstars had about 3,000 hits, and that was alpha carotene. So then we contrasted those 40 phytochemicals with the number of clinical studies that were done with them. And it was probably not remarkable, but and we published this plot. Quercetin had, as I say, I think it was 47 some thousand studies on it, and there were about 100 clinical studies that had been done on it. And anybody can look up most of those clinical studies in clinicaltrials.gov. It's a database that the U.S. government hosts, and it's got a lot of foreign studies, probably not all of them, but it includes, I think it's fair to say that if there's a decent clinical study going on, you'll probably see it posted in that database, although you won't 4 times out of 10, you won't see results. You'll see a promise for results. And so you may be able to track down results from those studies. So that was the most worked on phytochemical, had about 100 clinical studies. The compounds that had the most clinical studies, clinical trials in human beings were, I'll ask you to take a guess.
Sulforaphane.
No, I wish it was.
That would have been my guess.
Oh.
What's become legalized around America lately in state by state?
Marijuana.
Yeah. So it's
THC.
CBD, not THC, but it was CBD, cannabidiol. And N-acetylcysteine was another one, which is widely touted in the supplement industry, although there are reasons to be concerned about that. And they each had about 700 or 800 clinical studies, many ongoing with them. So I guess in a way that illustrates part of the problem, right? You've got, you can have a huge amount of information on a specific phytochemical. Quercetin happens to be a small molecule that's easily isolated, easily studied. It's present in a lot of plants like onions. It's good for you. It lights up antioxidant assays, which we talked about already. But then, frankly, I think one of the reasons it has not gotten more clinical attention is it's other than ways of delivering it, there are no patents associated with it that would enable a company to sort of monopolize it. So it's a plant compound. It's a phytochemical, and that's what we crow about all the time, and we want people to eat more of. But because of the way it's available in plants, it seems not to have struck the attention of a huge amount of those who do clinical studies and require money, big money, from the NIH or from food companies or drug companies or supplement companies. Whereas cannabidiol, I don't think I need to describe why that may be attractive to some people. It's put in pills and gummies mostly. You don't eat it in a plant. And N-acetylcysteine does require some isolation and purification, so that's also a supplement play. So there's a lot of sort of ancillary stuff going on that impacts the phytochemical research. It's not that it's difficult to do in cell culture, in vitro on the bench. It is expensive to take it to the clinic, and ultimately, as a physician, Kevin, you are not. I believe. I don't want to speak for you, but I believe you're not going to make recommendations to a client or to a patient based on, a lousy cell culture study that suggests, hey, this might be good for people. You're going to want to see clinical trials, maybe not, clinical trials with hundreds of thousands of people, across multiple sites, but at least you're going to want to see that in some clinical trials, this compound was shown to be safe and hopefully effective. So I think that's where the dilemma is. And it's a policy question as much as anything. We need policy that, I think, that identifies certain phytochemicals and starts putting directed clinical trials research into them. I wonder if that'll happen in my lifetime. It sure better happen in your lifetimes, or our health system is, well, I think our health system is headed towards disaster anyway, but it needs to happen, because we need to give people some confidence, more confidence than they have, that various phytochemicals are really valuable for their health span, for their enduring physical and mental performance before one day they just don't wake up.
So I have a quick question, and then I want to dive into sulforaphane, because that's obviously something that we're super passionate about, and you are the go-to person for it. So, but back to kind of to that point, do you see that, maybe in 10 years, or maybe hopefully sooner, or maybe 20 years, whatever it takes, do you see phytonutrients being, prescribed from a medical standpoint in these isolated single compounds? Or do you see them, because nature doesn't present to us one phytonutrient at a time, it presents it to us in this complicated food matrix, right? So an apple could probably have, a huge amount of different types of phytonutrients. Do you see that, do you foresee it as being prescribed as individual phytonutrients, or this, complicated, the top 100 kind of put together in this tablet? Or how do you see, and I kind of get to back to your point, I feel like the research realm, you almost have to study one nutrient and its effects, but I feel like it would take too long to actually get to anywhere with that. So is there a way, do you think it's going to be sped up by having to have these, combinations of the top phytonutrients?
So you're asking, in essence, a question about synergy, and additive or multiplicative effects, and you're asking a question about the food matrix,
Mhm.
the junk that is in the food that contains the phytochemicals. And obviously, the word junk is not highly technical, but we've talked about what that junk is. It's a protein, carbohydrate. It's all the stuff that's essential for life. But um, I mean, do I foresee prescriptive use of isolated phytochemicals? Yes. Although the catch there is, so I see it happening with naturopathic and integrative physicians. I don't see it happening in mainstream medicine for a long time. And the reason is because of the stranglehold that the pharmaceutical industry has on, I would argue, our lives, but certainly on medicine. And that's that, you take a plant compound, and sulforaphane, which we can talk about later, or quercetin are perfect examples, or beta carotene, pick any phytochemical, the name of which that comes from a plant, and it's already known, right? So US patent law, the US Patent and Trademark Office won't give you, if you're a pharma company, if you are one of the big pharmas or a small pharmaceutical company, they won't give you a patent for production of that compound or use of that compound exclusively by you to sell to consumers in a pill. Now, how do the drug companies get around that? Well, they take a plant compound or other natural compound, could be something isolated from a soil bacterium, and they work hard to develop analogs to it. So they say, okay, this compound is toxic if you give it at such and such a level, compound from plants. And it's good at doing this, but maybe not great. Maybe we can make it better. So they screw around with the molecule, they synthesize different molecules, and maybe they make the plant compound something like it a little bit better by putting a new functional group on it. Maybe they make it a little less toxic at very high concentrations. And bingo, they've got a new compound. They give it a funky number, RSD 52395. They write a patent, they get a patent, and then they're the only ones that can use it. And then they pay for a clinical trial or two, and all of a sudden it becomes valuable. And their shareholders love it, and they've got a new drug. Is it a plant? Is it a phytochemical? Nope, it isn't. Did a plant inspire it? It sure did. And their long lists of these compounds that were inspired by or created sort of in the image of phytochemicals. So, that's, and then the other thing that is patentable, therefore, which sort of spawns work by companies, is delivery systems can be patentable. So something like curcumin or resveratrol, which are really, really interesting and potent plant compounds, neither of them are very absorbable in the human body. So you may have to give 400 or 500 times the amount that's ultimately absorbed to get some absorbed. So I'm sure both of you have, read that. I think you can eat something like 8 grams of turmeric, which is the main source of curcumin. And that's a huge amount. I mean, that's a heaping tablespoonful of it. And that's a lot of flavored chana masala. Sorry. That's a lot of really good tasting food. But you can also, if you make that compound easier to solubilize and easier to absorb, you can get away with a fraction of a gram to get the same medicinal effect. So patenting delivery systems is another way that, in this case, supplement companies can use a plant compound and get intellectual property around it. So another part, your question was loaded with so many layers that I want to try to at least touch on a few more of them. Another part of your question really involves delivering the food matrix. In the best of all possible worlds, would you be better off just eating foods rich in various phytochemicals, a varied diet, plant forward or plant rich or plant exclusive for that matter, to get your phytochemicals? Absolutely, no question in my mind. There are a lot of good reasons, I think, to take supplements, especially as one gets older. If one has various medical problems, there are reasons to do it. If one is stressing one's body in various ways, like performance athletes. So there are reasons I think taking supplements makes sense. And in fact, Full disclosure, I also consult for a supplement company that makes sulforaphane from broccoli seeds, because I think sulforaphane supplements are a reasonable thing for some people to take. But what you lose when you take a supplement with individual plant compounds is you lose all of the synergy that so many of us think is there when you deliver the plant phytochemical in the matrix of the plant. And that is something that is not very well documented in the literature. It's presumed by so many people. And I absolutely believe in those matrix effects. But it's very, very difficult um, to prove experimentally, to show experimentally. But people are working on it. And, when I got into the business of phytochemistry a long, long time ago, we just didn't have the tools to look at the effects of, for example, more than two compounds together. I mean, the algorithms, the computational requirements, the the bench chemistry, the analytical instruments just weren't there. That dates me, I know, but sadly, but you just couldn't think about looking at, the effects of, say, pick the top 5 most interesting phytochemicals in a plant, in an edible plant, and looking at their interacting effects. You can actually start to do that now, or I say I use the term you loosely. Neither of you nor me are doing it, or probably could, but people are starting to be able to do that, which is very, very exciting. And I think in baby steps, we're getting towards that point where we can document, okay, slicing up some ginger root and putting it in your food, or slicing up some turmeric and putting it in your food is, 5 times better than taking a curcumin pill that gives the same dose of curcumin. Don't, I mean, that's not a quote, but that's an example of the kinds of things that I would hope sooner or later we'll be able to say, but I don't think we can now.
Awesome.
Okay. I think I left out one part of an answer to your question, but I don't like to talk forever without getting some feedback. So let me know.
I think it's time, part of the show, where we should shift gears and talk about sulforaphane since it's so important. So I'd like to get your expert opinion on broccoli sprouts, sulforaphane, and why they're so important.
Um, you know, the, I'm not suggesting that sulforaphane is the most important compound in our arsenal of phytochemicals at all. That would be ill-advised. However, I spent over a quarter of a century working on it, so I guess that's sort of a giveaway that I do think it's pretty important. Um, we started looking at it when my former mentor, who's now sadly died a couple of years ago in his mid-90s, Paul Talalay, and Yushin Zhang, his medical student at the time, who's actually also in Buffalo at the Roswell Park Cancer Institute. But Paul and Yushin rediscovered sulforaphane in broccoli. It had been documented in the literature, and it had sort of been discounted by people that were looking at compounds like sulforaphane for their antifungal effects. And I think this was in the 40s or 50s. And, it had some interesting antifungal effects, and then they sort of forgot about it. But Paul and Yushin discovered it because they were they had been looking at inducers, or at the time they didn't realize it was upregulators, but inducers of so-called phase 2 cytoprotective enzymes. So back in the late 80s, Paul made this just really landmark discovery that by giving certain compounds, and these did not include phytochemicals at the time, you could potentiate a cell culture system or animal model to protect itself ultimately against cancer. And so this was all directed at cancer at the time. And it was known, Paul just determined that inducing these phase 2 protective enzymes was one of the most important mechanisms. Then they started looking at plants, and they zeroed in on broccoli because broccoli had this protective mechanism in vitro in test tubes. And so then with Yushin, they said, okay, what the heck is it? What's doing it? So they they made an extract of the plant, and this was market stage broccoli, divided it up into 100 fractions, looked at each fraction, then looked at the fraction which was active in their assays, and ultimately isolated a tiny amount of sulforaphane. This actually was front page news in the New York Times, and there are a lot of jokes about broccoli made by George Bush Sr. and people who didn't like broccoli and so on. So it got a lot of attention to broccoli, which is probably the first time a vegetable got so much attention.
Right.
But then the questions became a little bit more serious, and Paul said, well, okay, how do we find more of this? How does a consumer, for example, know when he or she goes to the store, is this a good broccoli or a bad one? Is this loaded with this phytochemical or not? Do they all have the same amount? Long story short, I had been working on broccoli prior to that, but not on sulforaphane. He hired me to find better broccoli. I quickly determined that there was really no way to tell other than a chemical analysis, so that wasn't going to help the consumer. And then wound up growing smaller and smaller broccoli plants. The idea being that, well, it was born of practical reasons. I was in Baltimore in the wintertime, and I couldn't go out to the fields and couldn't travel back and forth to Southern California to get broccoli all days of the year. So I started growing sprouts in the lab, and had a sort of eureka moment and said, oh my gosh, there's tons more sulforaphane coming out of these things. And actually also discovered that it was glucoraphanin, which is a precursor that's very stable but not really biologically active, that occurs both in market stage broccoli and in broccoli sprouts. Long story short on that is, yeah, broccoli sprouts had a ton of the precursor of sulforaphane. They have the enzyme that converts that precursor, which is called glucoraphanin, to sulforaphane. And over the years, we and many, many others have discovered that, and I really truly mean that when I say and many, many others. It's been a worldwide. There's been a worldwide interest in sulforaphane. We have shown that there are many mechanisms of action of sulforaphane, and it has morphed from something that originally we were looking at for its cancer preventive properties to something that has clearly potent anti-inflammatory, immune response modulation, indirect antioxidant activity, even wound response and blood vessel dilation effects. It is part of the cascade that's involved in AGE detoxification, advanced glycation end products, which you know a lot about. It's involved in mitochondrial support, so it's involved in energy metabolism, and it's involved in antibiosis. All of these via different mechanisms, probably. So, for example, it's inhibitory, quite inhibitory to Helicobacter pylori, which causes ulcers and stomach cancer. So, this turned out to be a really powerhouse molecule, and therefore, I mean, I have on my counter right now three jars of sprouts. One is that I make growing, and I have them most of the time. One is lentils, one is clover, and one is broccoli. So, I grow broccoli sprouts. I wish there were better ways to buy broccoli sprouts without having to sprout them all the time. So I'm always looking for tasty foods that are rich in broccoli sprouts, and having them be shelf stable would be even better. Um, Wink, wink. I know someone who's doing that. So, yeah, I mean, it turned out that it's a really potent and interesting phytochemical that I think people should get. You know, do I think people should get more of? Yeah, I do. In the American diaspora or whatever that term is. Yeah, the American diaspora. If you're in the tropics, you're in a Pacific island, do I think you should grow broccoli sprouts or buy them? No. There are other foods with similar compounds there that are great for you. But if you have disposable income, because broccoli sprouts are expensive, and you can buy foods that contain them or buy them, yeah, I think you should. Unfortunately, fresh broccoli sprouts in the supermarket get funky really quickly and they get bad and they're not an ideal. I mean, a lot of people who want to like them wind up not liking them because what they get in the supermarket looks cruddy usually by the time they get them home and they sit in the refrigerator for a few days. They just don't keep very well. You asked
So
about sulforaphane, and I diverged, of course, but let's refocus me.
yeah, so sulforaphane is I mean it's an incredible nutrient and compound, we'll say, right? Because it all of the reasons that you listed. Well, that's one of the things that I could geek out forever about plants because they just have so many amazing effects. So it's I just think it's incredible, and that the fact that you guys were able to isolate like the compounds that were actually causing all of these various pathways, to occur is pretty amazing. So thank you for doing that because it not only does it remind us that we need to eat as many plants and as much plants as possible, but it reminds us to eat our broccoli, right? Which is, something everybody always really jokes about, but it really is, it can make the biggest difference because if one compound can have all of those effects that you just said, imagine if you had a huge, delicious salad with broccoli and radish and tomatoes and kale, and you just had this mega powerhouse, right? Like it's almost you can't even comprehend how much nutrients are going to be in that salad, right? So thank you for doing that. But for consumers, how much sulforaphane do you suggest that they get? Is there a magic number that you suggest?
Short answer, no, because I don't want to be held to it, and because I think it is still a moving target, frankly. But I think the epidemiologic literature suggests that a couple of servings of broccoli a day, market stage broccoli, are protective against, for example, colorectal cancer, perhaps breast cancer, prostate cancer, and certainly other 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 data with different and in some cases smaller data sets suggests that the same for a number of other conditions, chronic diseases. So 2 servings a day of market stage broccoli is a lot for most people to get. And one of the things that we said over and over again, sort of as we were trying to promote and push broccoli sprouts as a potential alternative, and I say push, I mean from a scientific perspective, we were trying to promote the fact that these are healthy and good for you. Um, a couple of ounces of broccoli sprouts, which is really, just a sort of a handful, is equivalent in its ultimately its sulforaphane content to something like a pound and a quarter of market stage broccoli. So they are much more potent. And I think most people are familiar with those clamshell packs that sprouts come in a lot in the supermarket. So like half of one of them is a good amount to have every other day or so. Couple of points come up. I use 2 words that trigger the need to say something else to you. Well, I said every other day or so. One of the really interesting things about this antioxidant concept is that, remember I called sulforaphane an indirect antioxidant because it induces protective enzymes. Those enzymes stay active for days, or in some cases something like a week or two at a time. There are a whole series of hundreds of such enzymes in your body. Some of them only remain active for a few hours, but we think, and there is published a small amount of data suggesting that you don't have to dose, if you will, with these things every day. So you don't have to chow down broccoli sprouts or cereal containing broccoli sprouts or supplements of broccoli sprouts every day. Probably every other day is a reasonable amount, or maybe even every couple of days, if you're looking to sort of quantify that in dose response terms. But there's a huge amount of work that still needs to be done on that. So the default position, if you're a supplement taker and if you're prescribing a supplement, would be, because you can't get people on a weird schedule, is take this low dose every day. If you're an eater, if you're eating food, and I dare say everybody is listening does eat food, then integrate something like broccoli sprouts or a food containing them into your diet, at least a few times a week, is, I think, a responsible way to project that or present it. The other trigger in our conversation, our just finished conversation, was the word epidemiologic. And I want to point out that, there has been a disconnect that bothers a lot of people in the lay public, and it bothers scientists too, between epidemiologic data that says something and then a clinical study that doesn't show something. So I'd like to make it very clear that now 2 generations, at least, maybe 3, of epidemiologists have done a huge body of work showing the value of fresh fruits and vegetables in preventing chronic disease, A, and B, showing for example, cancer preventive or cancer protective effect of eating cruciferous vegetables, B, and C, sorry, it sounds like a politician. Point 3, the protective effect of broccoli and cruciferous vegetables on specific cancers. So the first report I recall seeing on that specifically was in 1975 by someone by the name of Graham. And that work continued for decades. And, every now and then there'll be an epidemiologic study saying there's no effect. Most of them claim to show an effect, and statistically robust effect in many cases. But then someone does a clinical study giving the isolated compound, not broccoli, but giving sulforaphane, and doesn't see an effect. And they throw up their hands and say, well, that disproves all this epidemiology. Well, it doesn't. What it reminds us is that the epidemiology, looking at what people ate as actual food, embodies this matrix effect or this synergy that you were talking about. And it underscores that it's whole foods that are so important. And doing these clinical studies with isolated compounds, or even, you might argue, with highly purified derivatives that are rich in a compound, don't necessarily always work, because maybe they're targeting the wrong thing, and maybe because they don't have that food matrix to deliver the compound in. All right. Time for me to shut up again, but I made my 2 points. I'm happy.
I would like to know, I think a lot of our listeners would be interested to hear what you have to say about the human trials that have been done with sulforaphane. I know there's some studies out there, or at least a study I'm referring to, about sulforaphane with autism. But kind of what are there any chronic diseases or disease states where sulforaphane would be particularly beneficial?
So we've reviewed them recently in two or three separate papers in 2018, 19, and 20. And there have been, I'm going to misquote my own paper probably, but there have been something like 75 or so such studies. And I can certainly share our more recent summaries with you so that you can share that slide with your listeners. But of those 75 or so studies, many of them were looking at a specifically at biomarkers which were indicative of a cancer preventive effect. So, God, Kevin, you're giving me an opening to talk for hours again. So rein me in, buddy. But one of the things that you realize very quickly when you start looking at prevention of cancer is that that's not an endpoint that you can do inexpensively or easily, or even unless you give a whole lifetime of an investigator to it, right? Because prevention means eating a healthy diet from the time you're, I would argue, in utero, but certainly through a lifespan, and certainly in the early years of development. And you'd have to track people for years and years and years, and ideally give them certain foods, or at least do a good job of monitoring that consumption. So what happens when we look at cancer prevention is I don't I use the term loosely, epidemiologists um, have to look at biomarkers that indicate uh, risk, and indicate reduced risk. And so with that said, we and others have looked at biomarkers of liver cancer with sulforaphane, biomarkers of air pollution injury, which potentially could lead to lung cancer, but not necessarily, um, and biomarkers that of a variety of other conditions, and yes, found effects of sulforaphane. You specifically asked about autism. So there are a lot of neurological conditions which, in animal models and mechanistically, looking at the biochemistry of what we know happens, uh, would seem to be ideal targets for sulforaphane. And those include both neurodegenerative conditions like Alzheimer's and Parkinson's, and neurodevelopmental conditions like autism and perhaps schizophrenia. So we have to get in less than 5 minutes to get to an answer to your question about autism. Yeah, we've been involved with directly. I've been involved directly with about 8 studies now on those neurological conditions, um, most of them on autism. And we've been looking at biomarkers and looking at behavior. And so autism is something where you can look at behavioral changes. And in the first such study, which we published with a group at Harvard, Zimmerman, Dr. Andrew Zimmerman, the first author of that study was Kanwaljit Singh, and it was in 2014, published in the Proceedings of the National Academy of Sciences. We showed fairly dramatic changes in some of the stereotypic classic autism symptoms when these were young men, all of them, but when they were on a sulforaphane supplement. This is something that I actually made, so it was a broccoli sprout extract that was freeze dried. And when they went off that supplement, they reverted to more or less baseline conditions. And those who got a placebo didn't show that those changes. What we wanted to do, but were not able to do, and this all gets back to things we've been talking about, is we wanted to be able to tie that in with biochemical markers of autism and blood-based markers, because a lot of scientists like myself are much more comfortable seeing that, the numbers in a blood test change from this to this. Um, and that gives us much greater comfort that those parent observed changes in symptoms, or investigator, autism doctor, and observed changes in symptoms are real. because you always worry about a placebo effect, and everybody wants to see their kids get better, and so on and so forth. So there were five, I believe, five follow-up studies around the world, and I was involved in all of them. A couple of them have published and saw changes in biomarkers. And then there's a big study that was done in China, and that manuscript is in review right now. And there were changes shown in that. These things have been presented at international meetings now. So, I can share the fact that there were changes. We also were involved in two studies in schizophrenia, one in the US, and that has published, and there were no effects. There were no effects shown in the published paper, but in the talk that my collaborator, the principal investigator, Faith Dickerson, gave at a scientific meeting, she shared information that there were differences based on cognitive status. So there appear to have been some differences, but it wasn't the primary outcome. And then there's a trial in China that is also in peer review now, that we were involved with, and there appear to have been some differences in schizophrenia outcomes also. So all that is to say, there's a hell of a lot going on in this area, and as some of my other podcast friends say, stay tuned, right? Stay tuned to this channel.
Yeah, no, I mean, there's so many. Autism is it's estimated that's 1 in every 600 people are thought to have autism, and the number has more than doubled just in the last 2 decades, which is this is a very real and serious problem. I know my nephew has autism, and I listen in on a lot of those communities where these parents don't really have any options. So even if there is a glimmer of hope for them, right? Or something they can do that is as natural as broccoli, right? Or broccoli sprouts, or things that could potentially make even a little difference in their daily life with their children. I mean, that's huge. And I think that, just the fact that this is being studied is amazing, because this kind of really puts the power back in people's hand to really focus back on food for their children, which can make a huge difference. So thank you for being involved in all of that, because it is a really huge growing concern, and there's not many options for those suffering with autism right now. There's really not. So that's
Yeah.
amazing. Awesome. So
True.
yeah, yep. Someone else say?
So yeah, I mean that's so true. Actually, the rate of new incidents or new diagnoses of autism in children 8 years old, last time I checked, and I think it's gotten even worse, was 1 in 58. 1 in 58. That's unbelievable. I mean,
Wow.
it's very scary. And people don't. I mean, there are all sorts of theories, and yes, genetics is involved, but so is environment, and yeah, there's so much work to be done. I just point you to some anecdotes. We actually published these. It was the weirdest paper I've ever published, but we thought it was important to get it out there. After the study that I mentioned, the 2014 study, we followed up on those patients 3 years later and published a collection of essentially anecdotes from parents who many of whom chose to keep their kids on a sulforaphane supplement. And some of the reports are, I mean, they're just they're really very touching, and documenting, again, they're anecdotes, but documenting lasting and substantial, I mean, marked changes in behavior, improvements in behavior, and ability to be more mainstream with their kids. So yeah, I'll share that with you so you can post it on the podcast for anybody who's interested. But yeah, I say it's weird because scientists are trained not to publish anecdotes, right? But we did anyway. So
But those are also, those are real people that are experiencing
yeah,
these.
exactly,
So
exactly.
and obviously when it comes to your child, like I said, I really watch a lot of these groups, and they're really, something that is as safe as broccoli, right? And something as safe as sulforaphane, and just fruits and vegetables. That should be the main focus right now, because it is safe, and we know that kids need to eat anyway. So let's try to focus on how do we give the best advice for those that are suffering with it as these studies continue. So, but yeah, wow, 1 in 58. That's
remarkable.
Yeah. Awesome. Well, this has been incredible. And I kind of, we didn't even get to half the question that we wanted to ask because there's just so much to talk about. But Jed, this was really incredible. And I hope everybody listening got so much out of it. I know I feel like I'm going to go have so much broccoli sprouts right now. But Jed, thank you so much. This was incredible. And thank you for all the work you do and are continuing to do. And thanks for choosing, to support companies that are also trying to carry out the same mission. Your life's work is incredible. So thank you so much.
Always a pleasure learning from you, Jed.
Well, you're both too kind, but I appreciate having the platform to be able to talk with lay public and practitioners about stuff that got me up at 5 a.m. every day for years and years and years, and sometimes still does. So, yeah, I'm passionate about it, and if I can convey a little bit of that passion, I feel like we've had a successful podcast. So,
absolutely,
thanks.
Thank you so much.
Thanks for having me.
Of course. Thank you.
Okay. Bye-bye.
To everyone listening, thanks so much for joining us on this episode of #FoodTruth.
And if you share our mission for Food Truth, please be sure to rate, review, and subscribe, and visit antiages.org for more healthful tips and information.
And remember, don't forget to eat your broccoli.